Integrated Pest Management, otherwise known as IPM, controls pests in an environmentally sensitive way by frequently monitoring the plant's health and its pests so that you only use management strategies when they're needed. Integrated Pest Management is really a decision-making process. You assess the kind and number of pests you have, and then determine the best management tactic that helps your plant but is still environmentally sound. The adoption of IPM in your landscape can reduce the amount of pesticides you use by as much as 50 to 90% without sacrificing the appearance of your plants. The cardinal rule to using IPM effectively is to note that pests may not be the only threat to your plant. If you focus only on pests, you may miss any cultural or growth problems that commonly afflict plants. At the WSU Plant Diagnostic Laboratories, for example, half of the sick landscape plants that are brought in for diagnosis are not suffering from insects or disease, but from cultural and environmental factors such as overwatering, drought, sun scald, or winter damage.
Most of the problems that plants face in landscapes are not related to diseases or insects, but rather are cultural and environmental in nature. For example, not enough water, too much water, poor soil preparation, perhaps a lack of fertilizer nutrients. All of those things, as well as low temperature plant damage during the winter, can cause problems.
The first step in implementing an IPM program in your landscape is to identify and list all the plants in your yard. How can you take care of your plants if you don't know what they are? Next, do some homework. Find out your plant's cultural needs, what pests may cause them problems, and how sensitive are they to environmental influences. During your homework, you should discover the key plants in your landscape. These are the problem-prone plants that will require the most attention. Next, you'll need to determine the current key problems of each plant. Living or biotic organisms, such as insects, fungi, slugs, and deer, may attack your plant. Alternately, non-living or abiotic causes, such as weather, fertility, and too much or too little water, may be causing them undue stress. Now, study your landscape ecosystem. Yes, your garden truly is an ecosystem, with complex interrelationships among plants, animals, soil, weather, and other climatic factors, such as tolerance to minimum temperatures, sunny and shady areas, prevailing winds, and seasonal rain patterns. You will also need to understand your garden's soil and how well it drains water.
Understanding your soil is a key part of managing your garden. We know that the type of soil that you have is going to affect the selection of plants for your garden and how you're going to manage the garden to get the healthiest plants. One of the key parts of soil is its texture, or the different sized particles that we have in the soil. And something that's important to do in your garden is to check the texture of your soil. We know that soils that have a lot of sand in them are going to drain water very readily. Soils that have a lot of silt and clay will not drain water so readily, but that they'll hold a lot of water during the drier periods. When I estimate the texture of the soil, I simply pick up a sample. When the soil is dry, I'll use some water to moisten it up. And then first I'll feel for the grit. And the grit are the sand particles in the soil. Just by rubbing my thumb over it, I can feel a lot of grit in this soil, so I know it has a lot of sand in it. I estimate the silt by feeling how smooth it is. This one's not particularly smooth, so there's just a little bit of silt in it. And the amount of clay I estimate by modeling the soil, just like we did with clay when we were kids. And I make something called a ribbon, like this. The longer the ribbon, the more clay there is in the soil. This soil only makes a short ribbon, so I know there's not a lot of clay in it. This one has a little bit of clay, it has a little bit of silt and quite a bit of sand, so this one would be a sandy loam texture.
This information is essential if you want a healthy garden. Give your plants a fighting chance by carefully matching them to the areas in your yard where they're best suited. Your landscape is constantly adapting to its environment, so you'll need to persistently monitor all seasonal and long-term variations from the norm. This means that every 2 weeks during growing season, and at least every month in the winter, you'll need to chart plant changes such as stress, yellow, wilted leaves, or dead twigs, for example. This constant monitoring is a key element of integrated pest management. Concentrate your monitoring on your garden's key plants and their key problems. Know what pests to expect and learn about their biology. Of course, that's going to require a lot of homework. One way to monitor for pests is to use beating trays, traps, or just good old-fashioned visual observation. Some traps you can use are pheromone traps, colored traps, pitfall traps, and sticky traps. Once you've captured some pests, you can use some of the resources listed later in this video to identify them and recommend good, safe IPM practices to control them. So keep watching. For now, let's take the next step in creating a healthy landscape. At this point, you should have a good understanding of your plants, their pests, and your landscape ecosystem. Now you have the knowledge arsenal to be able to optimize your plant's health. You can start by selecting plants with unique characteristics, such as pest resistance, making it tough enough to battle your garden's particular failures. We call this using the right plant, right place strategy.
Eastern Washington is our dry side of the state, so it's important to remember to use drought-tolerant plants or even native plants in the landscape. This, for instance, is our native 9-bark, and this is ocean spray. But remember, no plant, whether it's native or drought-tolerant or what, is drought-tolerant the year that you plant it. So you've got to remember to plant it and keep it watered until it's established in the landscape.
Of course, you'll want a diverse selection of plants to limit pest infestations to any one species. Next, employ good cultural practices. If your soil is well drained, you can simply plant and backfill using just the native soil. However, if you have poor soil conditions, you can add organic matter. It's extremely important when adding organic matter to mix it into the entire planting area, not just the little hole where you intend to locate your plant. This applies to using potting soil as well.
One of the ways you can avoid landscape plant problems is to make sure that you're planting the plant properly. Many of our plants are bought as containerized plants, and they need a special attention to detail. And one of the things you absolutely have to be sure of is that when you plant the plant, that the root system is spread out. If they're matted, they have to be cut, and one way to do that is to slice the roots off the bottom of the plant and then slash the roots by inserting the point in and just pushing down and spreading them out that way. You spread the roots out with your fingers after that, put the plant in a planting hole, and then the plant will have a much better chance of surviving in a landscape.
Aside from proper planting, you need to pay careful attention to watering, fertilizing, and pruning in the future to promote total plant health. It's comparable to preventive health care in humans. If you exercise and eat right, you decrease the threat of developing health problems. Although we don't advocate exercising your plants, you can minimize cultural and environmental problems by starting them off right, and your plants will have a better chance to withstand insect or disease damage. To do this, you'll need to remember the steps to IPM that we've been discussing. Know your plants, determine key problems, biotic and abiotic, study landscape habitats, optimize plant health, and use IPM to manage pests. Remember, the crucial elements of a successful IPM program are correct diagnosis, monitoring, and familiarity with pests' life cycles. One note on monitoring pests for environmental conditions. Early season warming can trigger earlier than usual appearance of pests, resulting in earlier than usual damage to your plant. Also, differing levels of moisture through either rainfall or humidity can trigger certain diseases. Based on this, I'm sure you're now asking, so when should I manage pests, and are pests going to kill my plants? Of course, there are many factors involved in answering these questions, but the key is our individual subjective thresholds on how much damage we can tolerate. For the agricultural industry, the threshold is based on economics, while for a homeowner, the threshold may be more aesthetic in nature.
The economic threshold is a term that is more applicable to an agricultural situation than a landscape situation. It's defined as the point in time when a pest population is causing losses that equal the cost of control of the pest at that time. In other words, it's an equation. Whereas the tolerance threshold is a lot less easy to define. As I said, it's a personalized thing. For many, it's zero. Some people just can't stand the idea of having insects on their plants whatsoever. And they're very likely to spray when they see something that looks like a pest. And the point is that many deciduous trees, for example, and shrubs can take up to 25% damage to that tree or shrub before any real harm comes to the tree itself, as long as it's otherwise healthy.
Unfortunately, ignorance about the pest and the plant's ability to withstand some damage often results in unnecessary pesticide applications.
One of the things that I think folks who care for plants and landscapes must learn is tolerance, and to accept a certain amount of insect and disease damage on those plant materials. In most cases, healthy landscape plants, mature plants, are not going to suffer unduly because they've been attacked by insects and diseases. For example, we have here some root weevil damage on a mature landscape rhododendron. Although it may look rather strange and unusual, in the long run this is not going to cause the plant any serious harm at all.
There are 4 general methods used in IPM to manage insect, disease, and weed problems. These are cultural, biological, mechanical, and chemical. You can use any or all of these, or mix these methods together for an integrated management approach. Cultural management is simply changing the plant's environment to deter pests. It depends on knowledge of both the plant's needs and its potential problems. So let's start right by selecting plants for the site you have in mind. For example, rhododendrons need good drainage, moisture, and an acidic organic soil. If planted in poorly drained clay soils, you subject them to root rots. Many junipers cannot handle wet or poorly drained soil for the same reason. Avoid using key plants or pest-prone plants like skimmia, which has chronic spider mite problems, or spruce, which are often beleaguered by aphids. Many crabapple varieties have powdery mildew and scab problems, and true firs or Abies species have chronic balsam woolly adelgid problems. Choose resistant plants, ask known experts about them, or consult extension publications on the matter. Water management is critical to plant health. When installing a lawn sprinkler system, keep the sprinkler heads away from junipers, or conversely, keep the junipers away from the sprinkler heads, because junipers may attract root rots in wet soil conditions. Another cultural prevention method is to outcompete weeds by establishing dense ground covers in your landscape. Finally, if all else fails, rip it out. Plant removal is a perfectly viable cultural tool.
Don't be afraid to remove a problem plant from your landscape. This rose, we noticed last year, had a lot of powdery mildew and black spot disease on it. If we leave it here, it's going to affect other rose plants. So the best disease control method here is to just go ahead and dig out the whole plant and remove it. Roses are inexpensive, and we'll replace it with a disease-resistant variety and have a much better landscape.
Of course, in some cases, you may only need to prune out the infected material, letting the ailing plant live to fight another day.
Pruning can be important in a disease management program for several different reasons. One of the most important is removing diseased plant material. In this example here, we have some branches here infected with European canker. If we leave those cankers there, they're going to spread spores to the rest of the tree. So we see the canker, and we need to come back a good distance from those cankers and make a nice clean cut, and then we're removing that disease from the tree. Another thing we do in pruning is to open up the tree canopy, and this changes the environment and makes it less conducive to disease. So if we have a lot of extra branches, we want to prune these out to allow better air circulation. That helps the tree dry out quicker, and we have less potential for disease. Oh, here we've got another canker down here, so we want to be sure and get rid of that one also. So as we open this tree up, we're going to have less disease problems, and we're going to have better quality fruit next year.
The biological control method of pest management is a little more complicated to institute, requiring more research and forethought.
Biological control is the use of living organisms to control pest organisms. There are basically three methods involved in biological control, one of which is to protect what is already there. And a real good example of that is the use of something like Bacillus thuringiensis, or BT, which is a very selective insecticide that kills only certain types of insects. A second style or strategy would be the enhancement of biological control organisms already there. And a very good example of that would be in purchasing things like green lacewings, which can be purchased pretty easily to control targeted pests. A third method is that in which we introduce foreign beneficial insects to control introduced pest species. An example around here would be the purchase and release of cinnabar moth larvae to control tansy ragwort, an introduced pest.
If you opt to use beneficial agents, such as green lacewings, it's critical to pay attention to time of release and weather conditions for a successful release. Not all beneficial insects can be used under every circumstance, however. For instance, it's a mistake to use lady beetles on small tracts of land. Normally, lady beetles are collected during hibernation. Instinctually, they will take flight after hibernation, settling somewhere else to mate and subsequently lay eggs. It can be quite a surprise to the purchaser when their flock disappears a day or two after they're released. Mechanical management is most effective when pest populations are low because it requires almost individual attention to a pest. Pinching leaf rollers or applying stickum as a weevil barrier are examples of a mechanical control method. Mechanical control of weeds can be quite effective early in the season and can be accomplished by simply pulling weeds by hand or by shallow cultivation. Simply using various types of mulches, such as bark chips, can suppress weed seed germination. Under certain circumstances, chemical management can be effective. The philosophy of IPM practitioners, however, is to consider more selective materials first, like Bacillus thuringiensis, commonly known as BT. If you decide to use a broad-spectrum product, apply it selectively. Treat only the area or spot that's affected. Finally, for effective management, timing of application is critical. Pesticide applications or alternative strategies based on calendar dates are seldom used in IPM since they're often ineffective. Many disease and insect pests are closely related to plant growth cycles, such as timing of bud break or bloom. Therefore, it's better to time your management strategy according to the plant's growth cycle, which varies from region to region. If pesticide application does become necessary, first ask yourself these questions. Do I have the right equipment? Where on the plant is the pest feeding? Spider mites, for example, feed largely on the undersides of leaves, so your product needs to reach this location. How many applications are needed to break the pest's life cycle? Have I chosen the right product, and is it wholly effective? Can I use a product that's less harmful to beneficial insects? And finally, how much of the product do I need? It's not until you can answer all of these questions that you're ready to implement your chemical management strategy. Remember, IPM takes into account many methods of controlling insects, disease, and weeds, but it's up to you to do your homework. Get to know all the plants in your landscape. Determine your key plants and their key problems. Study your landscape ecosystem and monitor, monitor, monitor. If you have any further questions about IPM, visit your local extension office for a list of publications on the matter, and visit the HortSense website on the World Wide Web. By implementing integrated pest management, you have taken the first step in many in taking a more environmentally sensitive approach to managing pests and disease in your landscape. IPM requires a little more effort on your part, but in the end, I'm sure you'll think it well worth your time.